So you've got the note section here for cosmology, and we've been going through the last couple of weeks the introduction section, and we called it Back to the Beginning, and I jokingly called it Not That Beginning, because we talked about kind of the history of why do we have Pastor Larry up here teaching this, and then we talked about just the history of how we got to where we're at currently in modern science. And that was in large part due to answering an objection that I frequently had to answer as I talked with people about this subject, the Bible and science. And that was the objection that, well, the Bible just shuts down any scientific inquiry. And we took a look in great detail at the fact that that's not the case. In fact, the thing we think of now as modern science is what it is because of people who were Bible-believing people, who believed in a creator God, who created the universe to operate by rules that were comprehensible, you could understand. So this intelligent creator, rational being, created a world that can be rationally comprehended. And so they wanted to. And so they pursued their study of science to that end, and we looked at that in great detail. And so now we are going to actually try to go back to the beginning. And so that's why you have a section of notes in your hands there called cosmology. And I want to talk to you a little bit about what we have been learning in the last couple hundred years in cosmology that points us to some key things that the Bible says about where it all comes from and where we come from. And so we're going to talk a lot today about the Big Bang. And I just want to say at the outset, I'm going to talk about this because it's one of the dominant views in where did the universe come from. And it is the dominant view. And so we'll talk a lot about it and show how even that points to key truths that the Bible says about where it all comes from. But I wanted to say at the outset, I don't want you to be nervous. I'm not a Big Bang cosmologist guy. I don't think that is the right explanation of where it all comes from. But just to make sure that we reinforce what we said in the first couple of sessions, that the Bible is a science starter, I will start at that point. So this section's called The Heavens Declare, talking about how cosmology points us to what the Bible says about where we all come from. In the first section there on page 1, you see at the title there, I want to talk about the way that the finite universe points to a transcendent cause. And so how did we get to the cosmology that's dominant in our world of science today? You go all the way back to the 1800s. We talked a little bit last time about this guy named Pierre-Simon Laplace, and he was kind of known as the French Newton. A couple, 100 years later, he developed an explanation, as we talked about, of the formation and stability of our solar system that didn't call for divine intervention. So going back to Newton, you've got him publishing his Mathematical Principles of Natural Philosophy in 1687, in which he goes through derivations of Kepler's laws that are describing the motion of the planets. And so from his laws of motion and his laws of universal gravitation, Newton's working through all these things. However, Newton had privately developed the methods of calculus. All of his published work used cumbersome geometric reasoning, unsuitable to account for the more subtle, higher order effects and interactions between the planets. And I'm going to go back here. My notes are jumping back on me. There we go. Newton's working through all of how do the planets, so he's working through how do the planetary motions work, how can we understand the principles behind these, and he's doing the math, he's doing the calculus that goes into understanding all of these things, but he doubted the possibility that he could ever come up with a mathematically comprehensive solution to the whole. So he concluded, as we talked about briefly last time, that there had to be periodic divine intervention necessary to guarantee the stability of the solar system. So Laplace was working most of his scientific life against that type of approach. He wanted to prove that there didn't need to be any divine intervention to explain the motions of the planets and as the order of the heavens above us. And so we told the story about how kind of the apocryphal story, legend has it that he was explaining that to Emperor Napoleon. Napoleon said, well, where does God fit into all of this? And Laplace said, I have no need of that hypothesis, talking about Newton's idea that, well, every now and then God must intercede to keep everything running in order. I'm going to pause every now and then, apparently, because my notes are jumping out. I'm connected to the presentation, and I'm not sure why they're disconnecting. So the development of what's happening here with Laplace in astronomy is kind of coinciding with things that are going on in other areas of science at the same time. So you've got geology beginning to explain the formation of mountains and canyons, and all of the folks who are studying, or many, as I went through the scientists list last week, and I highlighted the ones with asterisks, how many of them had to do with geology and related fields around the time of Darwin. So they're starting to explain all of these topographical and features of Earth in terms of slow, gradual processes, slow, gradual, undirected processes. And in biology, you've got Darwin proposing theories about origins of completely new forms of life in terms of natural selection instead of what had been the dominant view, and that is design. So you've got the evolutionary biologist Douglas Futuyma saying, by coupling the undirected, purposeless variations to blind, uncaring processes of natural selection, Darwin made the theological or spiritual explanations of life processes superfluous. So he's saying here, this biologist is a man practicing recently, so he's a modern day biologist. He's looking back to this time that we're talking about, looking at what Darwin started offering as explanations and saying, so Darwin started explaining things in a way that allowed then people to say, all right, so we don't need a theological or a spiritual explanation of this. And even more recently, famously, biologist Richard Dawkins said that Darwin made it possible to be an intellectually fulfilled atheist. So this is highlighting the idea that Darwin's theory of evolution by natural selection promised a scientific explanation for the diversity and apparent design in life, thus removing the need for a supernatural creator. So you've got scientific progress, as it were, making it possible to explain things like our solar system, our planet, and then even life on our planet in purely naturalistic terms. So this is the direction that everything's going as science is progressing. The one thing that they struggled with providing an explanation for, in fact, that they still struggle to provide an explanation for, is, so all right, you've got the evolution of life on Earth, but how did that get started? That's still a mystery in that field. Or what about all the matter? So that's what we're talking about today in cosmology. Where did all the stuff come from? So not life is way down the line here in their model, but where did all the stuff that life's made up from come from? So back at that time, physicists who had adopted a naturalist or materialist philosophy believed that the universe was infinite in time and space. They assumed that the universe had just always existed. And so they had a model like you see laid out there in the middle of page 1. They had a materialist model of the universe. So they thought of the universe as something that was eternal, something that was self-existent. It didn't need a creator. It was self-creating, that it was self-organizing, that it was autonomous from any outside forces. There's nothing outside the universe. To them, the universe is everything that exists. The matter, that's it. There's nothing, no reality outside of that. So no design, no purpose, no God. This had started to become the trend until signs of the beginning. You see there in the next section. In the 1920s, before I say that, by the end of the 19th century, so you're heading into the end of the 1800s, the naturalist materialist worldview, or what we could call scientific materialism, had come into its own. It embraced a model in which material came first, and then eventually some of us, material, think of us as just matter in motion, some of us, material beings, thought of the idea of God. When the model for millennia before that had been the theistic model, and that is, first there is God, the uncreated one, and eventually he speaks the material universe into existence. So science progresses, and as science moves on, some unsettling discoveries happen. So in the 1920s, Edwin Hubble, a lawyer turned astronomer, has access to these giant telescopes. Here you see one of those. This is the Telescope Observatory at Mount Wilson. And there are these giant telescopes that allow scientists for the first time to look out into the night sky and these little points of light to be able to resolve them so that they could see detail there. They could see that there is, in fact, galaxies besides our own. So pause and think about this. That was in the 1920s. It's only 100 years ago. 100 years ago, we're going, there are other galaxies. That is not very long ago. I'm getting a little ahead of myself, but in a later lesson we'll talk about this. If you were to take the whole evolutionary model all the way back through cosmology and the billions of years, if you take your arm, this is the span of time that the universe has existed, and they put us on the tip of your fingernail. And it just boggles my mind how, if you believe that's the time scale, you can think you know much about anything. But even if you just think about a biblical time frame, 6 to 10,000 years that the world has been in existence, 100 years, that's the small amount of time we've even been aware that there is anything outside of our galaxy. So Hubble discovered that these tiny points of light had structure, they had shape. He discovered that as far back as we look into that field, that as you look back into just pick a space out in the night sky, as far back as you could look, there were just more and more galaxies, on and on and on. There's a telescope named in honor of this scientist, and in 2012, NASA took images that this telescope had captured called the Hubble Deep Field, and they made a video fly-through, and I just want to show you to give you a sense of the scale of what we're talking about. So if my plans go according to plan, which they don't always with technology, I'm going to hit a button here. It's going to show a video, and you'll get an idea of what we're talking about. So this image begins with a zoom sequence into the location of the Hubble Extreme Deep Field, and the deepest image of the cosmos that we've ever had until recently with the James Webb Space Telescope. And it's showing the relative positions of these galaxies they calculate this based on the redshift data from Hubble. So as you get into this one field, and then you see now all of the galaxies, all of this just appeared as one speck of light to us. And now as you go through, you can see the structure, different kinds of galaxies, different structures. And it's just amazing. If you ever get a chance to go to the Creation Museum down in northern Kentucky, just past the Ohio border, they've got a wonderful planetary presentation that helps you understand the scale of the universe even better than that. That was probably hard to see here. We've got light shining on the screens. So Hubble discovered that the further away a galaxy appeared, the faster it was receding as well. So this is evidence of what they call galactic recession and Hubble's law. It's the idea of the further, the faster. So you look out there, you see a galaxy, further away it is, the faster it's going. And they could tell this by what was called redshift. So it's kind of a visual equivalent of what's called the Doppler effect. So have you ever been standing in an area and a train goes by and you hear the whistle on the train and it comes by and it goes, "Wheew," and it changes tone as it goes by you? Well, the same thing happens with light. when light is moving away from you, it shifts more toward the red end of the spectrum. So they started seeing evidence of this, and I've got the fancy graphic up there that you don't understand and that I don't understand either. But the people who study this use this to show you how the further away something is. And, you know, when I see stuff like this, I frequently go, how do they know how far away that is? You know, it's not like we put a probe out and send it into space and check this. There's no way for us to check this out. But the people who do these kinds of studies put a lot of work into it. There's every reason to believe that these are probably really good guesses at how far things are. You look at creationist organizations like Creation Ministries International that was here recently, and they look at this and they see the same thing. And so it seems like it's a sound principle. And the idea, though, is, so as they looked out farther into the universe than we've ever been able to see, the things that appeared to be the furthest away were shifted more to the red spectrum. And so you got this idea of a galaxy that's a universe that is expanding. So his discoveries kind of really made concrete this idea that our universe is expanding. As time moves forward, everything in the universe appears to be moving away from everything else. So it's kind of like if you were to draw galaxies on the surface of a balloon and then blow the balloon up, that's kind of the picture of what's happening. And then that means if you let the air out of the balloon, what happens? All these things, if you're able to blow it up. I thought of bringing a balloon in and blowing it up as an illustration to show you, but I can't blow balloons up. When I try it, the air just shoots right out of my nose. So I thought I would spare you from that, not show you. Use your imagination. So if I blew a balloon up really big and it's got all these images of galaxies on it, and then I let the air out, what's going to happen? All of those galaxies that were moving away from each other are kind of running back in toward each other now. So if you run the clock backwards in what they're discovering back then, at some point you arrive back at a beginning to the expansion, a beginning to the universe. All right, that is significant. And so you've got a few years prior to Hubble's discovery, you've got a guy named Albert Einstein. His theories are leading him to the very same conclusion. His revisions of Newton's gravitational theory posited that if you had a massive body, so Einstein's doing studies on a bunch of things. Part of it has to do with gravity. And what he's learning is the way gravity works. So believe it or not, this is interject here, we still don't really fully understand gravity. That's another thing. So 100 years ago, we didn't know there was other galaxies. We're still trying to figure out I know we know what it is since Newton. You pick the item up, you drop it, it falls. Yes, we get that. Why does it fall? That part's really difficult, and we're still trying to figure it out. But Einstein's getting to the bottom of a lot of these things and has helped us to get a pretty good model to understand it. His theory was that if you have a massive body, it would actually curve space around it. So it's kind of like, here's a picture maybe illustrating it, if you could see that. So you've got a sun and the moon. And it was like if you took a bowling ball and put it on a trampoline, how it depresses in, but in 3 dimensions, which hurts my brain to try to think of. So you've got 3-dimensional space and you put a massive body in it, then the space doesn't just, I kind of think of it as, you put the massive body in the space and then the space disappears. Well, Einstein's theories say no, space bends around the thing so that when you've got a massive body, anything that gets close to it starts rolling into it. Just like if you had a bowling ball on a trampoline and you put a marble near it, it would start trying to roll into it. In fact, if you try to sling it past it, it would kind of do that loop thing, like when you drop a coin in one of those machines and it goes down the hole in the middle. That's the model that Einstein's coming up with regarding gravity. So if that were true, and the math involved in his theories gave him good reason to believe it was, then he had to work out how the mass in space causing space to contract. So you've got these objects all over, and the space is kind of around it is bending around it. That means, so you've got 2 massive objects, the space in between them is cramming together. How the mass in space causing space to contract still allowed for there to be plenty of spatial volume. In other words, there had to be some other force. Why isn't everything just collapsing in on itself? And we're discovering, later, they begin to discover it's going apart from each other. He's trying to figure out, how does it not just cave in on each other? So, in other words, there had to be another force. There had to be something in addition to and opposite of gravity at work, keeping everything from being compressed. And so this force countering gravity must be expanding. So if gravity's pulling everything together, whatever else this is, it's got to be pushing things apart. And his equations implied that the force of expansion was a little stronger than the force of gravity, and therefore the universe is expanding outward. That's what the theory of relativity implied. And he didn't like what that implied. He saw the implications, but he wasn't a fan of that. The implication was clearly that there must have been a cause to the universe that's not a part of the universe, something that is beyond the universe. So I'm going to do my little reset thing here again. Sorry, guys. Thankfully, it goes back to the same slide, if it'll let me go back there. Pastor Ken, what do they say? Live by technology, die by technology. All right. Well, I'll find my place in my notes here while this tries to load. So, few years prior to the discovery, Albert Einstein's theories are leading him to the very same conclusion. He's not a fan, bottom of page 1 there. The implication is there's something beyond the universe that's the cause of it. So he comes up with, in order to counter this implication of the math and the findings that he's having, and he comes up with something called the cosmological constant. And I've got an important note here, so I'm going to kill that app and see if I can launch it back and start from scratch here. There we go. All right, so the cosmological constant. This is a term that he added to his theory of general relativity that represents the energy density of empty space. And if you feel lost with that, don't feel bad. I'm quoting things that I read here. I kind of get it. But this is the math that's behind this. Nobody in this room could follow. We're listening to what the scientists say about this, and we're going, all right, we'll take your word for that. So Einstein is working through this theory of relativity, what's going on in empty space here. If you look it up now, you'll find that this cosmological constant that he developed to explain it is often associated with dark energy. We'll come back to that later, which is what they think causes the accelerating rate. Initially, Einstein introduced this to counter what his math was telling him, because he was trying to get the model to be a universe that was static, not expanding. The math, the theory was pointing to it's expanding, and he thought that can't be. So he introduces the cosmological constant. Look on the quote on page 2 there from kids. I'm going back to Encyclopedia. The quote there from Encyclopedia Britannica says, "The cosmological constant is a term reluctantly added by Albert Einstein to his equations of general relativity in order to obtain a solution to the equations that described a static universe, as he believed it to be at the time. The constant has the effect of a repulsive force that acts against gravitational attraction of matter in the universe." So you got gravity pulling in, cosmological constant posits a force that's pushing out a little bit harder, so the universe achieves a static state. And he called this introduction of the cosmological constant later, when he realized it was a mistake, it was a fudge factor that he was working in that he just inserted. He called it the biggest blunder of his life. And then as you look up in this definition here, they say, however, recent observations detected a repulsive force somewhat similar to the cosmological constant that's dubbed dark energy and is the dominant component of the universe. In fact, they say makes up 75% of the universe. But put a pin in that. We're going to come back to dark energy because the recent evidence for this being everywhere might be more like the cosmological constant, I think, than folks are willing to admit now. All right, so this is a picture. You can't see them there, little people. Albert Einstein, Edwin Hubble, and William and Walter Adams at the observatory in Pasadena. After seeing the evidence for himself, Einstein firsthand gets to look through, here's the explanations from Edwin Hubble, and he says, I now see a necessity for the beginning. He told that to the press. But this new development didn't sit well with materialists. You know, you get all this progress happening that allow them to be explaining things without God, and now here you have something pointing to a beginning. That's uncomfortable. In fact, Sir Arthur Eddington said of that, philosophically, the notion of a beginning to the present order is repugnant to me. I should like to find a genuine loophole. I simply do not believe that the present order of things started off with a bang. The expanding universe is preposterous. It leaves me cold. So he didn't like the idea, but you notice this was not his scientific opinion. This was philosophically speaking. And further, Robert Dick of Princeton says, an infinitely old universe would relieve us of the necessity of understanding the origin of matter at any finite time in the past. So, the reason this idea is resisted is because if matter can be infinite in time, then it can be the thing from which everything comes. You look around in the universe, look around our planet. If matter can just always be there, well then, all right, we can explain that. That's where everything comes from. It allows an escape from the ages-old claim that the philosophers and the theologians have been holding that there was a beginning, and that because the universe had a beginning, the universe had a cause that transcends itself. The cause can't be inside the universe if the universe had a beginning. The cause had to be from outside of the universe. Alan Sandage, an astronomer, a student of Edwin Hubble's, in fact, he helped him with the experimental work confirming the redshift and the expansion of the universe. He stated in a presentation, there's this conference in 1985, conference on the subject of human consciousness. And I got this quote. You can't look this up necessarily. I recorded this quote as I was listening to Dr. Stephen Meyer speak about it. He was at the conference, so he wrote down this quote that he was present for and heard. But he says in 1985, Alan Sandage, that here is evidence for what can only be described as a supernatural event. There is no way that this could have been predicted within the realm of physics as we know it. So he was a former agnostic speaking at this conference on human consciousness. He says this, and then he confessed at the conference that his work in the field of astronomy had convinced him that there must be a transcendent creator, and he was now a Christian. This was kind of scandalous at the time. So I mentioned an astrophysicist that I've found helpful over the years, and this is not, his story is not an uncommon story. This physicist that I had mentioned in previous lessons, her story is the same. Her parents were atheists. She had adopted their views as a young adult. She was headed to the university to study astrophysics, and as she did, her study, as her testimony says, her study in astrophysics and her specialty black holes led her to consider theism, and after investigating that further, she became a Christian. It is not uncommon for folks who study. We'll find this the same when we look in biology. The initial look out in science gave men the impression that they could explain everything without God, but then the further they looked, and in biology, we found that the closer, the smaller they looked, the more evidence they saw for a creator. Astronomer Robert Jastrow, in his book God and the Astronomers, observes this regarding these developments, and you look on the bottom of page 2 there at his quote. It says, "This is an exceedingly strange development, unexpected by all but the theologians. They've always accepted the word of the Bible. In the beginning, God created the heaven and the earth. It is unexpected because science has had such an extraordinary success in tracing the chain of cause and effect backward in time. For the scientists who's lived by his faith in the power of reason, so they're trusting in this cause effect, trace it back. And for the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He is about to conquer the highest peak. As he pulls himself over the final rock, he's greeted by a band of theologians who've been sitting there for centuries. Materialists who preferred there not be a beginning and the need for a cause to the universe outside of itself did not give up easily. So we're going to talk about some alternate theories that were proposed then. So we'll look first at the steady state theory beginning at the top of page 3 there. So you've got a figure by the name of Fred Hoyle. Sir Fred Hoyle was the architect of the steady state model of the universe. So this is 1947, 1948. I think I've got a typo in your notes there. It says 1974, so you can scratch that, fix that. It's 1947. And he's looking for a theory that allowed for the obvious expanding of the universe. At this point, it's undeniable, the universe is expanding. But he wanted a theory, an explanation for this expansion that didn't imply a beginning. So his model posited a universe that's always been expanding, but it's maintaining a steady density. So there's like I don't know if this is a right picture. My simplistic mind thinks of one of those toys that where if you kind of it's a tube, but it rolls inside of itself, and as you keep pulling it, it just kind of keeps going. That's probably a bad model of it, because I can tell there are elements from his model that aren't represented in that description, but I think of that just this kind of infinite expanding. So he's trying to think of a theory that allows for that. The challenge for him is that as a universe is expanding, in order to maintain the equilibrium, there needs to be more matter in the space. And so therefore, you have to have more matter. So they're trying to come up with an explanation that doesn't require matter to just pop into existence. So you got nothing, and then all of a sudden there's something. That's one of the big questions in physics and astrophysics to this day, is why is there something instead of nothing? If you're a materialist, you don't think there's anybody monkeying with the rules, nobody's in charge, everything just happens that happens, you've got to explain how there was nothing and then all of a sudden there started to be something. And so the problem with his recommended theory, the steady state, is that he just kind of drove the problem back a little further. He's got matter popping into existence on an ongoing basis. And so it's been referred to as the continuous creation model. So he didn't really solve the problem. He just kind of spread the mystery out over time. So you've got two theories. Now you've got the Big Bang theory developing. You've got the steady state theory. Same evidence, the expanding universe, trying to explain this. And so it's obvious that you're going to need more discoveries, more evidence to try to figure out, all right, which of these is correct. And then a new discovery is made, new evidence, the discovery of the cosmic microwave background. But so let's back up a bit. So there's a man by the name of George Gamow in the late 40s, 1940s, early 50s. He's proposed a way of testing those theories. He predicted that if everything began at a single hot, dense point, so the singularity that they talk about in the Big Bang, that this type of a single, dense, hot singularity would have produced radiation that should still be detectable. In fact, he predicted that it should be detectable in every direction and that it should measure about 2.7 degrees above Kelvin, 2.7 degrees above absolute zero. So, back to our story now. In 1965, two guys, Robert Wilson and Arno Penzias, are physicists. They're working at Bell Labs, and they keep getting interference. They've got this giant antenna they're listening to, and they keep getting interference, and they're trying to figure out what's going on here. Maybe it's birds interacting with the antenna. Maybe it's the noise of traffic. Can't figure out what it is. No matter what they try, they can't get rid of the interference. So they connect with another physicist, Robert Dicke, we mentioned earlier. I think I've got a typo in his name there. It's just Dicke. He helps them interpret this interference, and together they confirm that this is what's come to be called the cosmic microwave background. It's radiation that's just out there everywhere, in every direction you look, and it measures about 2.7 degrees above absolute zero. So this is just what was predicted by Gamow. And since then, there have been increasing discoveries, evidence that causes those who are proponents of the Big Bang over the steady state, which is pretty much everybody now, people from a materialist perspective, to see that, all right, this is the way the evidence is leaning. So Hoyle eventually admitted that his theory was wrong. But there are other perspectives as well, other theories proposed. So take a look at page 4. There's a theory called the oscillating universe theory. And so this theory says, all right, so if you trace the clock back, it gets infinitely small. But maybe it's like a yo-yo, or maybe like an oscillating fan, something that goes back. That's what I think of when I think of oscillating. So maybe it's that the universe expands, but something happens and causes it to contract again, and it's just kind of oscillating, bigger and smaller, so that what you end up with, if you've got this process happening over and over again, is you end up with a model that sees the universe kind of going back and forth from a big bang, expanding, and then what they call the big crunch, ending in a big crunch, and then going back again. So you got this oscillating universe. So what does the evidence say? The mechanism that would cause the collapse of this model would be gravity, right? So you got everything expanding. Eventually, at some point, gravity causes it to collapse back on itself. Gravity is the product. Remember the trampoline? What is gravity caused by? It's mass bending space-time. I got ahead of myself there. Bending space. They don't know the thing about time yet. They're getting there with Einstein. But the question is there enough mass in the universe to cause that collapse? And it turns out there is not. There's not nearly enough. There's only a small fraction of the matter that would be required for a collapse like one in the oscillating universe theory to happen. There's only a small percentage of that in existence in the universe. And further, not only have we discovered that the universe is expanding, but we think it's increasing. So it's not like, expanding and then kind of slowing until it finally collapses back, kind of like a yo-yo going down and then slow and then stop and then reverse direction. As they look out further, remember the Hubble principle, the further the faster. So they're looking out there and they're like, it's speeding up. So it's the expansion force is vastly outstripping the gravitational force. So that brings us then to middle of page 4, kind of the model. Back to the model. Creation out of nothing. We think of that as the religious, the theistic model. But this is where the evidence is leading even the materialists. It's leading back to creation out of nothing. In 1968, a physicist named Stephen Hawking was able to solve the field equations of general relativity. And the implication in his solution was that if you could go back in time, the curvature of space-time, that's one thing they refer to space-time as a thing because time and space are so integrally connected that you have to think of them as one entity. If you go back, the curvature of space-time would get infinitely tight, and if you go back far enough, boom, zero spatial volume. So according to Hawking's solution, not only is there a 0 point in time that you wind the clock back and, all right, there's a beginning, the universe begins, but there is also a 0 point in space. Zero spatial volume. How much matter can you fit into zero spatial volume? Zero. And so the obvious implications of these developments, they can be a little unsettling if you're a materialist. If you're a materialist and your philosophy says that matter is all there is, and everything's pointing to matter didn't exist at one point, the evidence we get from the theory of general relativity and the Big Bang cosmology, that is the dominant view today, is remarkably similar to the idea of creation ex nihilo, creation out of nothing, that the Bible presents to us in the book of Genesis. So even using the most popular theory of cosmic origins among cosmologists today, not necessarily the one I hold to, but the one that's most widely held, we're finding that if we go back far enough in time, you get to a place where time itself begins. You go back far enough in space, you get to a place where space just evaporates, along with matter and all of the energy in it. So listen to, And this will probably be where we end off for today. At least listen to this summary of the problem that this poses for materialists from the mathematician and philosopher David Berlinski. He holds a PhD in philosophy from Princeton, and he is a brilliant mathematician. He isn't a Christian, but if you look him up online, they will say that he works for the Discovery Institute, who promote pseudoscientific theories, is the way he's described. But again, he's not a Christian. He would say he has theistic leanings, but I think it's from what he finds with all that we're talking about. So here's what he says, and so there's volume on this, guys. I don't know if the volume's turned on.
Was the dominant view, the thing, the universe. It's been there from everlasting. It will be there till everlasting. It's just hanging there in space. It was there for all time. It will be there for all time. And there is no further question that we need to ask about its creation. And the astonishing fact that the universe seems to be finite in temporal extent. It popped.
So there we go. So I think you see where this is going. Should I try it again, guys, or is that it? Try it again? All right, here we go. David Berlinski.
Cosmology, for example. Until 1930, 1940, 1950, Einstein's view was the dominant view, the thing, the universe. It's been there from everlasting. It will be there till everlasting. It's just hanging there in space. It was there for all time. It will be there for all time. And there is no further question that we need to ask about its creation. And the astonishing fact that the universe seems to be finite in temporal extent. It popped into existence 14 or 15 billion years ago. All of a sudden made many sympathetic observers say, oh, wait a second, I've heard that before. I mean, there's something resonant in that view in the beginning. It's not clear. I remember it from Sunday school in the beginning. Something about created the heaven. Well, you know, isn't that pretty close to what the Big Bang guys are saying? Yeah, it is pretty close. It is astonishingly close. And honest and sympathetic physicists said so. And for a long time, Einstein resisted this view. Till the end of his life, in fact, he found the Big Bang hypothesis personally repugnant. I have that on the authority of his friends. But many other physicists who had thought that all theological questions, especially questions about a creator, had been once and forever settled, were forced to confront a body of observational and theoretical evidence that made them wobble, as it should have. It should make every thinking person wobble.
You've got here clear evidence from the perspective of the materialist that what the theologians have been saying is pointing in the right direction. And so then you have guys like David Berlinski who are not Bible-believing Christians acknowledging this. So people acknowledging this in the various fields. And I call out, if you were to look him up, you will see descriptions of him attempting to discredit him. And it's not based on any evidence or that he's saying anything that's untrue according to their own theories. It's that he's pointing to the uncomfortable implication of that. And so I mentioned the special, the Ben Stein kind of documentary that was done a decade or so ago. And they highlight, in fact, if you look at the list of scientists that I shared with you in last section's notes of modern scientists on the creation.com website, at the bottom of that list, they have detailed accounts of the ways that some of those folks are treated prejudicially in the various institutions they come from, because they don't just toe the line of millions of years and accidental materialism. And so there's definitely something going on philosophically here. But for now, I just wanted to trace where does the scientific evidence point. We'll pick that back up on page 5, talking about the astrophysics aspect of that next week. Thanks for coming, and we'll see you next week.